All right, here's your homework on the remainder theorem or synthetic substitution. So if I want to practice my substitution skills, I can do it by dividing. So I take the 2 and I divide it into 4, 10, negative 15, and negative 20. I'm going to drop the 4, I'm going to multiply, and I'm going to add. I'm going to multiply, and then I'm going to add, if I can add correctly here. And then multiply, and then add. And then this answer is what I'm looking for. So when you plug in 2, the answer is 21. Again, I want to evaluate at negative 1. That's at 2, negative 4, 5, negative 9, and I need the 0 at the end. So we have 2, negative 6, 6, 11, negative 20, 20. So there's your answer. So the function at negative 11 equals 20. Number 3, I'm evaluating at 3. That's 2 and 6 and negative 2 and negative 1 and negative 14. I get negative 20. Let me put the lines in there. Double, double, check. And you have your answer. And so make sure you write your answer. Don't leave the answer like that. Write down what you did. So to evaluate at negative 3 equals, that's the answer I'm looking for. Can you evaluate at 4? I have 3x to the 4th, negative 9. I'm missing x squared, negative 24 and negative 48. So 3, 12, 3, 12. 48, 24. And then 80 and 90, I think that's 96. And so 96 take away 48, can I do it? Is that 48? Looks good. So if you evaluate at 4, the answer is 48. That's called synthetic substitution. Next, we're going to use the factor theorem. So if I want to know if this is a factor, I take the 0, that's negative 6, and I divide it in and see if the remainder is 0. That's the remainder theorem. So 3, negative 18, negative 5, 30, negative 2, 12, and what's left over is, so it works, by the way, so check mark. Now I'm going to check 2, but I'm going to see from the answer. So 3, negative 5, negative 2. Perfect. Now I'm going to check the next one. I don't think it'll work. That's 3 and 1. It doesn't work. So it didn't give me 0. So this one's bad. So the first 2 are factors and the last one is not. Let's try it again. So x minus 1, use positive 1 into 4, 52, 87, negative 13, negative 20. So it should give me 0. Am I doing it? These numbers are going to get large. 13, 9, that's 143. What did I do? Oh, 1's not going to work. So as soon as you realize it's not going to give you 0 at the end, it's gone. So the next one was negative 11. Let's see if that one works. It seemed odd from the beginning. 1. So 4, 52, 87, negative 13, and negative 22. That's 4. That's negative 44. That is 8. That's negative 88. That's negative 1. That's 11. That's negative 2. That's 22. That one works. It gave me 0. That's a check mark. Then the last one is negative 2. And I'm going to do from the answer. So 4, 8, negative 1, negative 2. You can do it from either one. Both, if they give you 0, will work. This one's shorter. That's negative 8, 0, and that's also good. So the first one doesn't work, but the next 2 do. And the factor theorem, if it gives you the remainder of 0, then that is a factor of that equation. Turn the page. Number 7, use the factor theorem to completely factor this. So positive 4, 1, 6, negative 16, negative 96. Then what's left over, I'm going to factor. So the two numbers that multiply to 24 and add to 10. So all together, we started with x minus 4, and then x plus 6, and then x plus 4. So try again. If I have that, so it's negative 6, I'm going to divide first. Then it has a remainder of 0 because it is a factor. I have 2x squared, x, and negative 21. So if I multiply 2 times negative 21, so the two numbers would be 7 and negative 6. So we got positive 7, we have negative 6, divide by 2, and that's 2x plus 7. 6 divided by 2 is 3, and then we have the one we started with, which was x plus 6, and then those are all my factors. So what I started with, and then there we go. Number 9. Here we go. We need the 0. So that's 16, that's 48. That's negative 9, negative 27. That all gives me 0 at the end. So this is, oh, and I could have factored out an x to begin with. Let me do that. So if I factor out an x, then I don't need this line at the end. So if I factor out an x, it would be x, then 6x cubed minus 48x squared minus 9x plus 27. Then it's the same work. And then what's left over is 16x squared minus 9. That's a difference of squares. That's 4x plus 3. And 4x subtract 3. Square root each one. So put it all together. We started with, I'm going to start with x. Then the first factor was x minus 3. Then we had 4x plus 3 and 4x minus 3. Number 10. So negative 4. So we have 1, negative 4. 4 times 26. What do you think? 80 and 20, that's 104, right? 0, negative 100. All right. So I have 1 less, so it's 1x to the 4th, no x cubed, minus 26x squared, no x's, plus 25. So we're going to factor this like a trinomial. So the two numbers are negative 1 and negative 26. But we're going to use x squared. Negative 25 and negative 1. And then both of these are a difference of squares. So we start with what we start with, x plus 4. Then this is x plus 1, x minus 1 by square rooting. This one, difference of squares, square root, is x plus 5, x minus 5. And there they all are. Okay, last one for your homework. Number 11. The value of a rare baseball card is issued in 1989. This gives you the value. X is the years, and the remainder. Find the value of the card in 99. So that's like 10 years later, right? So you can go 0.2, negative 0.25, 3, and 4. Let's see if I can do this. So 0.2, 10 times 0.2 is just 2. 2 take away a quarter is $1.75. Multiply by 10. And then 17.5 times 3. 15, 21, 2. That's 5. Move the decimals. That's 52.5. And then times 10. That's 525. And then add this up. And the price of the card is $529. That's what I got. All right, Mr. G Math over and out. Till next time, good job. Check in your homework.